good. All right, so we're going to take all the derivative stuff you learned in chapters 2 and 3 at the end of last semester. And now we're going to move into what they're good for and what they're used for. So, we're going to apply these to real situations. And how do biologists use this? And how do economists use this? And how do social scientists use this? And how do physicists use this? Okay, where are we going to see all of this stuff showing up in real life? When they talk about things like, in COVID, we wanted to flatten the curve, when that was the language that we had right at the like a year and a half ago. That's all. It's very smart mathematical people figuring out what those numbers are and how that's all going to work. So it actually means something. It actually has applications. That's where we're going to start. This whole chapter is going to be about. First, sorry, hang on. Okay. We need to get a few things so we're talking about the same thing so that we're on the same page. I need to tell you what an absolute, global, local, relative extrema is. Okay, we'll cover that first just so we're all clear. It sounds a big mouthful, but you'll get it right away once you see a picture of it. We're going to learn one theorem today, and then we're going to learn about a test called the candidates test. So all of that is in day 1. So let's just kind of start with this first theorem. Okay, it's called the extreme value theorem. Okay, so we have extreme sports, we have extreme lots of things. It just means that they're way out there. Okay, so if somebody is totally extreme, they're just, they're extremely high, extremely low. It can be totally the spectrum of it. All right, so here's the theorem that we got to start with today. Starts with the fact that a function has to be what type of function? Okay, what does it mean to be continuous? Just in your own.
No corner? No.
Say that again?
No cusp.
Oh, no, it can have a cusp. That's differentiable. You're thinking about differentiable. What does it mean to be continuous?
With the left-hand limit and right-hand limit.
Oh, yeah, you're being so fancy, talking about limits. Yeah, that's very good. It's very good. But it just can't be broken. What kind of brokenness did we talk about last year? Okay, gap, jump. What else?
Infinite, absolute.
Okay, like having an asymptote, can't have one of those. How about the little teeny hole gap that was there? Removable, okay? So to be it has to be continuous. So no brokenness, no missing points, no gaps, no jumps, nothing of that. No, has to be continuous. That's first. Okay, it also has to be closed. That means it has to have 2 endpoints on either side. Okay, so those 2 things are required. Continuity, and it has to be closed. Okay, so if those things are true, then the function has at least, and fill in the blank, 2. At least 2 what we call extreme values on that interval. And those 2 would be at least 1 maximum and at least 1 minimum. Now, if it's not a continuous function, then you're not guaranteed anything. But if it is a continuous function and has 2 closed endpoints, then you have 2 what we call extreme values. An extreme value is either a max or it's a min, and you'll have at least 1 of each, if not more. So let's look at a picture. Okay, here's a function. It is closed. It's continuous. There are no breaks, and it's closed. There's an endpoint on the left, and there's an endpoint on the right. So we're guaranteed at least 2 extreme values. In fact, this one has 5. We're guaranteed at least 1 minimum. And this one, in fact, has what we call 2 minimums. Okay, there's a minimum here, and there's a minimum here. Okay, they are minimums, meaning that they are the lowest point. One of them is the low point on the end, and the other one is the low point because it comes to a dip there. Okay, those are both called minimums. Now, they are different kinds of minimums, and this is where I need to teach you the vocabulary. Okay, which one is the lower of the 2 minimums? Which one is the minimum of the minimums? The first one. Okay, we call that an absolute, or AKA global minimum. Okay, the minimum of the minimums, we call that absolute or global. Global, thinking about the whole world, like it is this In the whole entirety, it is the smallest of the small, it is the lowest of the low, it is the minimum of the minimum, or we call it the absolute. Okay, the other one is called a local or relative minimum. Those two words are synonymous. So it's still a minimum, it's just not the smallest minimum possible, okay? It's a dip, it's a low, but it's not the smallest. So in terms of the maximums, we have the same kind of language. We have the maximum of the maximums, and that one is happening right here at that cusp thing that Jeffrey was talking about. So that is called the absolute or global of the maximums because it's the highest of the high. And the other two maximums, the other maximum is a relative or local. So you can use either word. Now what about the very last one? Okay, the one over here on the end. It's a minimum. Is it a absolute global minimum or is it a relative local minimum?
Which one?
The very last one. Is it an absolute global? Okay, in order to be absolute global, it has to be the lowest of all of the minimums combined.
It's a normal minimum.
Okay, it is a local minimum. Okay, this is a relative local because it's not the lowest one. There can only be one absolute. There can be one absolute minimum. There can be one absolute maximum. The rest of them are considered relative local. Okay, so just keep that in mind. Well, you know what? I guess there could be two if they were exactly tied. If you had two maximums that were exactly level with each other, they could both be absolutes. But otherwise, you would only have one. Okay, so here's kind of the, yeah.
So since the left side absolute global minimum is like the lowest, that minimum can't be absolute global since the left side is the lowest.
Right,
Okay.
right. Okay, so let's kind of classify how these extreme values happen. Okay, extreme values can be found at endpoints. Okay, we just saw on the picture above that we found an extreme value. Think when you hear extreme, think max and min. And it was on a closed interval, so remember that it has to be true. So you can find them at endpoints, and we did. We found one of them at an endpoint. We can also find them at what are called critical points. And there are two kinds of critical points that we could find them at. Okay. One are critical points where the derivative is 0. And that looks like this or this. Okay, those are places where you have a maximum with a rounded top or a minimum with a rounded bottom, and the derivative is 0 because they have horizontal tangents right there at those places. So that's one kind. The other kind is when the derivative is undefined. And that's what Jeffrey was talking about, corners and cusps. That could be at a corner, like that, or it could be at a cusp, like that. So you just need to know where to look. You got to make sure you look at the endpoints to see if they are the absolutes. Or if they're not, then you look at the critical points and the two kinds of critical points, where both either the derivative is 0, which is a soft rounded one, or where the derivative is undefined, where you have more of a corner. Those could be your critical points as well. So those are called the candidates. Okay, that's where you want to look. Okay, so let's classify the ones that from the same picture. Okay, this absolute, which we identified earlier here, that was an endpoint. And then on the other endpoint, we had a local or a relative, and that was an endpoint. So we classify those. The other minimum at point E, where there's that other minimum right there, that is where the derivative is 0. I can tell because it has a horizontal slope, and so that's where the derivative is 0. There's another place where the derivative is 0. That's at this local max. The derivative is 0 there also. And then the final one is where we have a cusp going on, and that's where the derivative is undefined, right here. So those are the types of places. It'll either be an endpoint, or it'll be where the derivative is 0, or it will be where the derivative is undefined. These are called the candidates. And the candidates are only at those 3 types of places: endpoints, derivative being 0, or derivative being undefined. All right. So how can you find a critical point or one of these candidates if you're not looking at a graph? Hey, looking at a graph is easy. I can say, look at the graph and point out the maximum or point out the minimum. Most of you can do that, fine. But if you don't have a graph to look at, is there a way to do it? And so yeah, we're going to take the derivative stuff we just learned and we're going to work on that. So first you want to set the derivative equal to 0 and cross multiply. That'll help you find some of them. So you do it by hand. You work out the math. Instead of looking at a graph, you work it out. We call this analytical. Or you can set the derivative equal to 1 over 0. That's undefined. Remember? 1 over 0 is the undefined. And then cross multiply. And that would also work to find you the extreme values. So remember, you either have endpoints or you do one of these 2 things. You set your derivative equal to 0 or you set your derivative equal to undefined. That's how you find them without looking at a graph. Okay, so let's just quick look at a couple pictures. Yeah, Nate?
Can you go back up?
Yeah, sorry. Which part did you need?
Okay.
Got it? Okay. Okay, so Nick, on picture A, the first picture, point A, what type is that? What's happening right there? Okay, is it an endpoint?
No.
Okay. Okay, it's where the derivative is undefined. Okay, good. And is it a max or a min, and what kind?
It's a minimum absolute.
Okay, absolute minimum. Okay, in other words, so he's saying it's the derivative is undefined. He can tell that because it's a corner or cusp. He sees that it's a minimum, and he believes it to be the absolute because he believes it to be the lowest of the low. Now, here's how low it is. That end point over there, now are you absolutely sure that your point A is lower than the end point on the end?
Mine would look even.
They look even, so it's hard to tell, right? From the naked eye, it's hard to tell. They might be exactly even or, okay? So I don't know if I could say it was the absolute unless I was for 100% certain, okay? So be a little bit careful about that. All right, Nate, how about B?
That's the absolute max.
Okay, and are you 100% sure it's the absolute max? Because here, let's see, that's about how high it is, right? And if I go over to the end point over here, are you 100% sure that that's the absolute max?
No.
Okay, it's hard to tell, isn't it? Okay, from the naked eye, it is difficult to tell, are these two, are they even, are they tied, are they level, or is one actually lower than the other? So it's hard to tell, I would just caution you against looking at a graph unless you were 100% sure about that, okay? Okay, Sue, how about point A on this picture?
That's absolute minimum.
Okay, absolute minimum. So he says it's a minimum, it is, so it's about that level. but I see a point down here, the end point, that's way lower. That one's much farther below. So I don't think we can say that that is an absolute minimum. I think we can only say that that is a local or a relative minimum. It also has the derivative equal to 0 and not equal to undefined. Okay, Leo, what do you think about B?
Local maximum.
Okay, good. I would agree with that. I think right there, because we've got a maximum up here, an absolute that's much higher, but I would say that this is a local, or we could use the word relative either way, and that's a relative max. And again, that's where the first derivative is equal to 0. All right, any questions so far? We're going to skip the next one because it's just the backwards picture of the other one we looked at, so I think it's fine. All right, so let's go to this one that has the yellow boxes on it. Can you go there? Okay, so I just want to recreate this drawing again for us. The first one is endpoints. You should always check your endpoints first, okay? I would say that that's the number one thing to check. Okay, then we check critical points, and there are two kinds of critical points. The two critical points are derivative is 0, and that would be number 2, and the derivative is undefined, and that would be number 3. Okay, these are what we call the candidates. So now I'm going to teach you the candidates test. Okay, all 3 of these are the candidates. And as Nate and Nick saw on that last picture, it was really hard for them to tell if it was an absolute or not. They couldn't necessarily trust their eyes according to the image to see if it was the highest of the high or the lowest of the lows. All right, so what we have to do, and I'll just zoom in on that, is for each of those 3 yellow boxes that are the candidates, we need to compare their y values. So we would need to go back to the equation, plug in the number wherever it is, and see what the y value is. And are they, if they come out the same, then they are equal and they're both absolutes. But if one of them comes up higher than the other or lower, then only one of them is the absolute. So that is the candidates test, where you take all 3 of those yellow boxes as candidates. It's like picking a captain for a team, right? You might have the whole soccer team out there, and then you say the candidates for captain are the seniors. So that eliminates a bunch of people. And then from the seniors, you want to pick the captain that you're going to have. All right, so we have a bunch of things, and we say, okay, we're only going to pick the candidates from the endpoints and from the derivatives being equal to 0 or undefined. And from those, we're going to compare their y values, and we'll pick the absolute from both of those. So that is called the candidates test. All right, so let's actually practice this. Okay, use the candidates test to find the absolute maximum minimum for this equation. All right, so step number 1, always check your endpoints first. My endpoints are 0 and 6 according to the interval. So I want to plug 0 into the equation, and I want to plug 6 into the equation. All right, so you probably don't want to do this math mentally, so grab your calculators out so that we can plug these numbers in a little bit more easily. So plugging 0 in is really no problem. I can plug 0 in, so f of 0 gives me 0 cubed minus 75 times 0 plus 100. I can do that in my head, and I get 100. That's a pretty big number. But I want to make sure that it is the absolute of the biggest numbers. So now I want to find f of 6. So I'll plug 6 in, and I'll get 6 cubed minus 75 times 6 plus 100. All right, can somebody figure that out for me and tell me what we get? Sue, do you have your calculator with you today? Okay, good. Kira, do you have yours?
Yeah.
Okay, why don't you grab that? So I'll give different of you jobs to do so that we don't all have to work on it. Nate, have you gotten it already? What'd you get? Negative 130 what? 134. Okay. All right. So we've got our candidates are so far the end points. But we want to find out if there's any other points that might be higher or lower than these before we declare them to be the absolute. So for the second step, we want to find our critical points, and we're going to do f prime of x equals 0. So I need to figure out f prime. So this is where we have to be, oh, okay, I got to remember how to do my derivative. Okay, who wants to do the derivative of x cubed minus 75x plus 100?
3x cubed, negative 75.
Okay, 3x squared minus 75. Okay, good. So now we're going to set that equal to 0. First, I want to factor that. You might notice that 3 is common to 75, so this would be 3 times x squared minus 25. And then that can be factored, and x squared minus 25 can be factored into x minus 5 and x plus 5, and that gets set equal to 0. So the solutions when we set 3 and x minus 5 and x plus 5 equal to 0 are give me more candidates, and my other candidates are now 5 and negative 5. So now I want to check f of 5, and I want to check f of negative 5, and these are my additional candidates that could be the absolute. So I'll have 5 plugged into the original, 5 cubed minus 75 times 5. Noah, can you do this one? Plus 100. Okay, and then I'm going to do negative 5. So that would be negative 5 cubed minus 75 times negative 5. Jeffrey, can you do this one? Plus 100. Okay. Do you have your calculator or no?
No.
Oh, okay. Then maybe, Kira, you can do it. All right. Noah?
Negative 150.
Negative 150. Okay. And Kira's figuring hers out. Make sure to use parentheses because his negatives really need those parentheses. All right, what'd you get? Positive 350. Okay. So I have a couple more candidates. Remember, these are all candidates for the absolute. And the last one is finding for step 3 that same f prime set equal to 1 over 0. But in this case, setting it equal to 1 over 0 and cross multiplying doesn't give me anything, so I have no new candidates. Okay, so now I just need to identify which one is the absolute max and which one is the absolute min. All right, so what would you declare? Which candidate is the max of the maxes? What's the highest value?
300.
Okay, 350 is a pretty big number. Okay, 350 came from the candidate of negative 5. However, there's a problem with the candidate of negative 5. Does anybody see what that problem is?
That's not very cool.
It's not in the interval. The interval has to only be between 0 and 6. And since negative 5 is not in that interval, I cannot include that as a viable candidate. So then that only leaves me with what as my absolute max? I think 100 is the highest of the high. So f of 0 equals 100 is my absolute max. And then I can also identify my absolute min, which would be the lowest of the low. I'm pretty sure that's going to be negative 150. And double check that negative 150 came from the candidate of 5, and 5 is in the interval between 0 and 50. So my absolute min is f of 5 equals negative 150. And I never looked at a graph once. But I know that this graph has an absolute max and it has an absolute min. But I did not use a graph to find it. Okay, any questions about that one? Okay, let's try another one. Okay, here's an ln. Use the candidates test to find the absolute extrema, again, maximum, minimum, for this graph on 2 to 5. So once again, our first job is to check the endpoints. And so my endpoints would be 2, f of 2, and f of 5. So again, we're going to need calculators out. That would be really helpful. Jesse, you don't have yours today? Okay. So f of 2 means plug in the natural log of 2 times 2 minus 1, and then figure out this is going to be a decimal number. And then the ln of 2 times 5 minus 1, which will also be decimal. Okay. Sue, can you do the first one? And Jesse, can you do the second one? Has anybody got it? You got the second one?
2.197.
Okay. Sue?
1.0. Just 1.1.
1 point what?
1.099.
099. Okay, great. All right, thanks. So far, those are my first two candidates. Now, I need to do the other ones by finding my derivative and setting my derivative both equal to 0 and undefined. Okay, does anybody remember how to do the derivative of an ln?
1 over.
Okay, 1 over
What's inside the parentheses?
what's inside the parentheses, which is 2x minus 1, then times what?
Yeah.
Not quite. It does have something to do with e, ln e, because the base of this, and then what always is important to come last? The chain rule, which is going to be what?
Just
2. All right, so my numerator turns out to be 2, and my denominator, since ln e is equal to 1, my denominator is 2x minus 1. All right, that's my derivative. So I want to take that and I want to set it equal to 0 and cross multiply, and I want to set it equal to 1 over 0 and cross multiply. So I'll do both. So I'm going to set it equal to 0 over 1, so 0 on the top, 1 on the bottom, cross multiply that. When I cross multiply that, I get 2 equals 0, which is no solution. So there are no more candidates from doing it that way. So let's redo it. And now let's set it equal to 1 over 0. So we're doing both. And now we'll do 1 over 0, and we'll cross multiply. And this time, we get 2x minus 1 equals 0, so x is half. So there's my other candidate, f of half. Nick, can you do that one for me? So this will be ln of 2 times half minus 1. And then tell me what that turns out to be.
Wait, so this would be number 3?
We haven't, yes, that would be number 3. We didn't get anything for number 2. What's the matter, Nick? You get an error. Why are we getting an error? Come on, same thing we saw last time. Why'd we throw one out last time?
It wasn't in there.
Okay, we just got half. Is half in the interval?
No.
Half is not in the interval, so we have to throw that one out too. Okay, so be watchful. Okay, watch to see if your candidates turn out to be in the interval or not. That's why he was getting error, because it wasn't in the interval. Okay, so we've covered everything, and now we just need to declare the absolute max and the absolute min, and we only have 2 to choose from. So my absolute max is f of 5, which is 2.197, and my absolute min is the other one, which is f of 2, being 1.099. And again, we didn't look at the graph, but we could tell what the max and the min were just by doing the math. All right, I'm hoping to get through a couple more with you. All right, here's another one. Find the candidate's test. It's the same thing. Okay, so here we're just our job tonight is to practice finding the absolutes. All right, so number 1, we want to find our endpoints So that would be f of negative 1, and it would be f of 3. So that would be plugging in negative 1 into the equation. And the other one would be plugging in 3 into the equation. And then number 2, we'll be doing our critical points. And I'm going to assign these to different people with calculators to figure them out for us. My f prime. Okay, so now we got to remember, how do I do a derivative of this one? Okay, this one's going to have an ln in it also. So this would be the same, it has 3 parts. 5 to the x squared minus 6 is the first part. The second part is the ln, and do you remember what the ln is of?
Isn't it ln5?
It is ln 5, good job. Okay, and the last part is always the chain rule of the x squared minus 6. So that would be 2x. And we'd want to set that equal to 0. And the only candidate, I'll do the math already, it turns out to be 0. Okay, that's the only one. Is 0 in my interval? Okay, so it's going to be a viable candidate, so I want 0. That'll be f of 0, or 5 to the 0 squared minus 6. Okay, so Christine, can you do f of negative 1 for me? Figure it out. You don't have one. Leo, can you do f of 3, please, and figure that out? And Jesse, can you do f of 0? Figure that one out. Okay, while you guys are doing that, I'm going to set it equal to undefined. So that's number 3, also a critical point. So while you guys are doing that, so I'm going to take my f prime and set it equal to undefined. So 5 to the x squared minus 6, and then ln 5, and then 2x set equal to 1 over 0, and that gives me no answers. So, okay, Christine, I gave it to you. What'd you get?
What, -1?
Straight out negative 1?
Yes.
Really? No, like, decimals or anything? That's 5 to the negative 5. I double check that a minute. Jesse did it, or no, Leo, I gave you f of 3, right?
Yeah.
What'd you get?
195.
100 and what?
95.
25. Okay, and Jesse, I gave you this one.
It's a weird decimal.
That's okay.
Yeah, so it's like 6. Well, that's how I might calculate it. It's like 6.4. And then like E letter. I forgot to read that. It's
Okay.
like -5.
Okay, so 6.4 e to the negative 5. That's exponent of scientific notation. So that means move your decimal, and if it's 5 times to the so that's going to be a really tiny number. So it'll be like over here, 1, 2, 3, 4, 5. So 0, 0, 0, 0, 6, 4. Okay, so super small. Okay, Christine.
Mine is 0.00032.
Okay, 0.00032, and Jesse's was 0.00064. Okay, so we have Jesse and Christine both have very, very small numbers, but let's declare between the two of them before we go, which one is the absolute, well, the max is easy. The max is f of 3 is 125, and then the absolute min. All right, who's lower, Christine or Jesse? Jesse is smaller because he's got more decimals. So 0.0000, oops, 64, and he gets to be the absolute min. I was just going to do a few more examples of the kind of the same thing, but the process is the same each time. Okay, make sure you check your endpoints, and make sure you check your critical points, and then declare what's the absolute max and what's the absolute. So some of your homework is going to be, you get to just look at a graph and just pick it off the graph. But the rest of it will be like this, where you're doing it by hand to find it. Okay?
When you do 1 over 0 and 0 over 1?
Both, all the time.
On both. Did we do it on this one?
We did. I did it while Christine, I did it on my 1 over 0, but there was no cross. No, here, let me pause this a second.